Solve problem on balancing of several masses rotating in different planes by using graphical method. Given question, a shaft carries four masses in parallel planes A, B, C and D in this order along its length. The masses at B and C are 18 kg and 12.5 kg respectively, and each has an eccentricity of 60 mm. The masses at A and D have an eccentricity of 80 mm. The angle between the masses at B and C is 100 degree and between masses B and A is 190 degree, both being measured in the same direction. The axial distance between plane A and B is 100 mm and between B and C is 200 mm. If the shaft is in complete dynamic balance, determine first magnitude of masses A and D, second distance between planes A and D, third angular position of mass at D.
In this question, four masses A, B, C and D are rotating in different planes about the shaft and the system is dynamically balanced. From the given data, we will draw the diagram for the arrangement of masses rotating in different planes as well as angular position of the masses. Now, if we observe the mass B, that is MB 18 kg, MC 12.5 kg. So these masses are mentioned. Now the eccentricity for this mass B and C is mentioned and that is equal to 60 mm. So how to plot this eccentricity? So we know that the masses are rotating about the shaft with angular velocity omega. So for the shaft we will draw this horizontal line, and this horizontal line is nothing but the rotation of the shaft and all the masses are rotating with angular velocity omega. Now eccentricity means these masses are placed at a distance of 60 mm from the shaft. So we have to show that. Now in the same way, eccentricity for the masses A and D is also given and that is equal to 80 mm. So we have to consider the standard unit, that is meter. So we can say that RB is equal to RC is equal to 0.06 meter and RA is equal to RD is equal to 0.08 meter. Now we have to plot the axial distance for these different planes because the masses are rotating in different planes. So here the distance is given. So distance in between A and B is 100 mm. So 100 mm, that is 0.1 meter, and distance between B and C is also given 200 mm. So we will first take this mass A. So for this mass A, eccentricity is 80 mm, that is the vertical distance about this shaft is 80 mm. So we will consider here with scale, that is 8 cm. So for 80 mm we will draw here one line for 8 cm and we will show this as a MA. Now we will move to the next, that is MB. So MB is 18 kg. So this mass is mentioned, and from this A, plane B, that is placed for 0.1 meter or 100 mm. So we will consider here some horizontal distance and we will show this as a 0.1 meter. And we will show the next mass MB. So eccentricity is 60 mm. So we will consider as a 0.06 meter and we will take scale for a 6 cm. And we will show this MB. So this MB is equal to 18 kg. Then next we have to plot the mass C. So how to plot, because the distance in between B and C is also mentioned. So this is the axial distance between the planes. So these are the different planes around which the masses are rotating. So 200 millimeters. So whatever distance we have taken here, we have to double or multiply with 2 and we have to plot this. So eccentricity, that is the distance is given for C, is also 60 millimeters. So we will take here 6 centimeter distance and we will plot here. So mass C, MC is also given and that is equal to 12.5 kilogram. Now we will move next. So next is mass D. So if we observe, the distance is not mentioned, that is the axial distance is not mentioned and we have to find out this. So we don't know. So we will place here any random line, or we will draw here random line, but its eccentricity is given and that is equal to 80 millimeters. So we have to draw this line as a 8 centimeter and we will show here the mass MD. Now this mass MD is not also mentioned. Now from this question we have to find out two masses, that is MA as well as MD, and we have to find out this distance. Now we will move to the next diagram, angular position of masses. From the given data, angle for mass C as well as mass A is mentioned with reference to the mass B. So we will consider the theta angle for mass B is equal to 0 degree, and with reference to this mass B we will plot the angle for mass C as well as mass A. So how to plot this angle 0 degree? So we have to plot this mass B in positive x direction. So first we will consider this as a center and here we will take one particular length. Now to plot the mass B, we know that the eccentricity is 60 millimeters. So again we will take the same scale, that is 6 centimeter, and at a distance of 6 centimeter we will plot here mass B, that is MB, and angle is 0 degree. Now with reference to this mass B, what is the mass C? 100 degree. So again with the help of protractor, so this center we have to keep at this point O and we have to select one point at 100 degree and then we will draw here one line. Now we have to plot this mass C which is at 100 degree. So eccentricity for C is also 60 millimeter. That is again we have to take the same distance, that is 6 centimeter, and we will plot here mass C, that is MC. And we will also mention the angle. So this angle is 100 degree. Now we will move next, that is theta A. So it is 190 degree. So after this 180 degree, that is this horizontal line, if I extend, then here this 180 degree is getting completed. And after this 180 degree, if I extend this up to 10 degree, then again we have to draw one line. Now for this theta A eccentricity, that is the distance is 80 millimeter. So we have to draw the length, that is equal to 8 centimeter. So we will show here. So this will be MA, that is mass A. So this angular position diagram is getting completed and we will also show this angle, and this angle is equal to 190 degree. To find out the unknown terms by using graphical method, we have to draw the couple polygon as well as force polygon. So we will find out the force as well as couple for the given data. Now there are total 4 planes about which the masses are rotating. So this mass MA is rotating about this plane A. This is the plane B, plane C as well as plane D. So in the first column we will plot these planes A, B, C and D. Now next column is for mass. So if we observe this diagram, mass for this A is not given. So we will write here as a MA. Then for B it is 18 kilogram, for C it is 12.5 kilogram, and mass D is also not mentioned and we have to find out. So I will write here as a MD. Now next one, eccentricity, or we can say the radius of rotation. So the radius of rotation for this mass A, Ma is given, and that is 0.08 meter. For the mass B and C is also mentioned in question, and that is 0.06 meter. And for the mass D is also mentioned in question, and that is 0.08 meter. Now we will move to calculate the centrifugal force. So what is the formula for centrifugal force? And that is mr omega square. So due to the rotation of all these masses about the axis, there is the centrifugal force, and that is getting developed, and which is equal to mr omega square. But the shaft as well as these masses are rotating with same angular velocity omega. So we will consider here centrifugal force is equal to m into r, and that is unit is kilogram meter, because mass is in kilogram and r is in meter. So we will fill this table. So for the plane A, this MA is unknown. So we will write here 0.08 MA. Now for this plane B, 18 into 0.06, 1.08. For C, 12.5 into 0.06, 0.75, and for D it is 0.08 MD. Now we will move to the next. Now this L. So L, that means the distance in between these different planes. So we have to find out this. Now if we observe here, there are two unknown terms, that is for the mass A as well as mass D. So we will consider in between A and D that one plane as a reference plane. So remember here, out of total 4 planes, we have to select any one plane that is unknown. So in between A and D, I will select this plane A as a reference plane. So we have to mention this as a reference plane, that is RP. Now the axial distance in between these different planes we have to mention in this column, and which is in meter. Now if we observe this plane A as a reference plane, so distance of this A from A, that is equal to 0. So we have to write here as a 0. Then the distance of this plane B from A, so we have to calculate the distance from this reference plane. So that is equal to 0.1 meter, and that is mentioned in question. Then distance of this plane C from A. So in question, distance in between B and C is given, but we have to calculate the distance from the reference plane, that is 0.1 plus 0.2, that is 0.3 meter. And the distance of this plane D from A, so that is unknown. So we can also write 0.3 plus x, or we can take here the unknown term, that is we will take LD, that is distance L of this plane D, that is LD. Now we will move to the next, that is couple. So how to calculate couple? So couple, that means this force multiplied by this axial distance from the reference plane. So C is equal to MRL, and its a unit is kilogram meter square. So just multiply this F and L, because F is equal to MR. So it's 0.08 MA into 0, that is 0. Then 1.08 into 0.108, and here 0.75 into 0.3, 0.225. And here we have to multiply this, that is 0.08 into MD into LD. Now we will move next, theta in degree. So that is also mentioned in question. So what is the angle A? So angle for this mass A is 190 degree. Then angle B, so angle B is 0 degree. Then angle C, theta C is 100 degree. And theta D is unknown, and we have to find out this. If we observe the column for this force as well as couple, then for force there are two unknown terms. But for the couple there is only one unknown term, and that's why we will first draw the couple polygon. Now we have to draw with some suitable scale. Now if we observe the values for couple, then it is 0.108, 0.225. So we will consider here scale 1 centimeter is equal to 0.01 kilogram meter square. Now as per this scale, we will first take this plane B. Now for this plane B, the value is 0.108. So as per scale, we have to take 10.8 centimeter. Now what is the angle for B? So if we observe, it is at 0 degree. Now the couple value is having positive sign, and we have to draw the line. Direction is towards the right hand side because of this positive value. So first I will consider one point as a point O, and I will take the horizontal line at a distance of 10.8 centimeters. So here is the point O, and here is the next point, that is point B. Now the after point B, so I will show here the direction, and now what is the value of this line O to B? That is 0.108. So we have to mention here. Now after that we will select for next plane C. So for this plane C, it's 0.225. So as per this scale, its value is 22.5. Now for this plane C, if we observe, angle is 100 degree. So with the help of protractor, how to select this 100 degree? So I will show here with the help of red marker. So from this point B, draw here one construction line. And now from this reference line, select one point at an angle of 100 degree. So here is the 100 degree mark. So draw the line passing through that, and what is the length? 22.5 centimeter. So we will select here 22.5 centimeter. And here is the next point, that is point C. Now the first polygon, couple polygon should be closed. So we have to join this point C as well as point O, because the next term, that is for the D, is the unknown term, and this length will show this value. So if I join this B and C, the direction is in the upward direction, and its value is 0.225. So this is our construction to join this point C as well as O. So I will use the red marker. Now what is the value for this? So I will show arrow also, and its value is 0.08 MDLD. Now we have to measure the angle for this plane D. So how to measure? So from this point C, we will draw here one construction line, and now we have to measure this total angle. So with the help of protractor, we know that if I draw this one horizontal line, then this total angle upward this horizontal line is 180 degree. So if I measure the angle remaining, then it is equal to 72 degree. So 180 plus 72, that is equal to 252 degree. So we can say that theta D is equal to 252 degree. Now what is the measurement of this scale? That is from C to O. So C to O, if we measure, then we will get that is equal to 23.5 centimeter. And its a value we have to convert into kilogram meter square. So 1 centimeter is equal to 0.01 kilogram meter square. So we will multiply here 23.5 into 0.01, and which is equal to 0.08 MDLD. So when we simplify this, then we will get MDLD is equal to 2.9375. Now we will move to draw false polygon in which two terms are unknown, for plane A as well as for plane D. Now we will consider some suitable scale, and scale 1 centimeter is equal to 0.1 kilogram meter. So as per this scale, for the plane B, we have to take 1.08 kilogram meter is equal to 10 centimeter, and for plane C 0.75 kilogram meter is equal to 7.5 centimeter. So first we will consider the initial point, that is point O. So I will take here the reference point O. Now for the plane B we will take here 10.8 centimeter. Now for plane B, if we observe, this is the positive value for the force. So we have to show the direction towards the right hand side, and the angle for B is 0 degree. So we will draw here one line, and that is 10.8 centimeter. So next point, that will be the point B. So I will show here the point B. Now we will move next for the point C. So for the point C, we have to consider the scale 7.5 centimeter. If we observe this diagram, what is the angle? So angle is 100 degree. So we will transfer this angle, because this mass MC is placed at an angle of 100 degree. So I will take here the line parallel to this with the help of roller, and I will transfer here, and we will draw one line, and length of line, that is equal to 7.5. So with the help of scale we will mark here one point, and that will be the point C. Now there are two unknown terms for the plane D as well as plane A. So how to draw this? So if we observe, for this D, direction is known for this couple polygon. So we will transfer the same direction. So I will show here direction from O to B towards right, B to C in the upward direction. Now for this direction of D, that is in the downward direction, and here this point O as well as point D, because this is for this line couple polygon is for this couple for point D, that is from C to D. So here I will transfer this same, that is I will transfer this line from couple polygon to the force polygon. And this point we will consider as the point D. Now here point B is there, point C is there, as well as point D is there. So what is the remaining point? That is point A. Now angle for this point A is given, and that is equal to 190 degree. So we will transfer this line, because this mass MA is placed at an angle of 190 degree. So we will transfer this line and to this force polygon diagram and passing through point C. So here if I transfer this, then this point of intersection is nothing but point A. So in this way this force polygon is getting closed. Now what is the value for this O to B? So value for this O to B is 1.08. So I will mention here. Then value for this B to C, it is 0.75. So I will mention here. Then value for this C to A. So for C to A, that means it is for plane A, and it is 0.08 MA. So I will mention here 0.08 MA. And value from this A to D. So last point is D, that means it is 0.08 MD. 0.08 MD. Now we have to measure this distance A to C as well as distance A to D, and we will then multiply with scale, and then we have to find out these unknown terms. Now this distance CA is equal to 7.5 centimeters. So I will show arrow also, and we will multiply with scale, that is 0.1. So this 7.5 centimeter into 0.1 kilogram meter, which is equal to 0.75 kilogram meter. So it's 0.08 MA is equal to 0.75, and that's why MA, that is the mass of A, is equal to 9.73 kilogram, and this is the answer. Then we will move to the next, that is distance O to A, or we can say D to A. So this distance DA is equal to 6 centimeters. So we have to multiply with scale, that is 0.1 kilogram meter. So answer is 0.6 kilogram meter and which is equal to 0.08 md. So md, that is the mass of D, is equal to 7.5 kilogram. So this is the second answer. Now we will find out the distance of this plane D from the reference plane. So how to find out? So from the coupled polygon we have MD LD is equal to 2.9375. So this MD is known. So when we put this value, then we will get the distance LD is equal to 0.39 meter. So remember, this LD is the distance from the reference plane, because we have to measure the distance from reference plane. So we will plot here 0.39 meter. Now from the coupled polygon we get the angle theta D is equal to 252 degree. So from with the help of protractor we can draw here the angle 252 degree and we will show this mass MD. Or the second way is to transfer this line. So this line is also at 252 degree, and that's why if I transfer this line with the help of this roller, then here we will show the MD. So here what is the eccentricity? That is 0.08 meter. So as per the scale we can take here 8 centimeter distance and we will show here MD, and we will show also angle, that is 252 degree.